So the f of prime of x, let's take a look at that. That's 1 over 2 plus sine x, and using chain rule, we have a cosine x over here. Setting it equal to 0, you have cosine of x equal to 0. Drawing a cosine curve, we have 0 to pi. Okay, and since we're given the domain is from pi to 2 pi, the only one that's viable is x equal to 3 pi over 2. Okay, now this is our critical points. From here, in order to know if it's min or max, we have a couple of things. Since we know natural log of x is a monotone function in that it's always increasing function, so we're going to have a minimum because f of pi is equal to natural log of 2 plus sine of pi. Is here you can see it. So sine of a pi, let's draw the sine curve. Pi is 0, so you have a natural log of 2. Okay. F of 2 pi, it's the same thing. Okay. So it's going to be a monotone function, so it's going to be a minimum here. That's one way you can tell. Another way you can tell, it's a little more rigorous in that you find what the second derivative is. It's a little messy, but it's not too bad. So what we're going to do is going to take derivative of the first one, which is the cosine x, it's minus sine x. Okay. Multiply by the second one, leave it alone. Okay. Minus, let's leave the first one alone, take derivative of the second one, which is cosine x. Okay. And the denominator is 2 plus sine of x, the whole thing squared. Let's keep on simplifying it a little bit. So you have minus 2 sine x minus sine square x minus cosine square x divided by the whole thing squared. I didn't bother to write the square again. Now this one is sine of x. If you put the minus sign inside the parentheses, you see this side is actually equal to 1. Okay, it's because the trig identity. On the bottom, we still have this whole thing squared. One more step over there. Minus sine of x minus 1 divided by the whole thing squared. Okay, this is the f double of prime, second derivative. Now, evaluate it at critical point of 3 pi over 2, we see that's minus 2 times minus 1, the whole thing on the bottom is positive. So indeed, this is actually a positive. Now, positive second derivative means concavity-wise, it's a concave up. Concave up gave us the minimum. Okay. Now, let's finish one more step here. So, at f of x, when x is equal to 3 pi over 2, let's evaluate. We have natural log of 2 plus sine of 3 pi over 2. This is equal to natural log of 1, which gives us 0. So minimum value is 0. So let's do a quick review of what we did here. We're given a function, asked to find the minimum and absolute min or absolute maximum. The way we did it, first of all, the first block here, all we did is find what the critical point is. The critical point is where first derivative equal to 0. From there, looking at the function, we know it's a monotone increaser, so we're going to have a minimum. But more rigorously, we actually proved that using second derivative evaluated at the critical point, we have a concave up, because it's bigger than 0 here. Since it's concave up, it gave us the minimum here. And evaluated it back into the function of the critical point, so we see the minimum value is 0. So during the period of we were given, we have two initial conditions, that's here and here, and then the function dips down to 0 over here. Okay, hope this helped. Have a confident day.